Okay, here we have version 7.5 where the beginning variable is written defined as 0 to start by default. Here we can change it in the sequence to any corner we would like, but 0 is default. And then we have it wait until the button is pressed, where the robot just doesn't take off. We can wait for it. And then to confirm that it has begun, it says hello, where there's a 2-second timer that waits and displays sequence mode. Press again, where if you press the button again, it sets the variable to the state of true, which here we enter our main loop, where that sequence or that state is read as true or false, where if it's pressed, it's running this state. If it's not pressed again, then it's running this state, which is just the default line track. We have a custom MyBlock here that uses one sensor to track it, where if a robot does not have two sensors, then it can just use the one in the default mode. Inside of that, we have our wait for the sensor to be pressed, which it should actually be a touch sensor bumped on port 4. Which here we have it on port 4, here we have it on port 4, so the start and stop button is on port 4. With our primary sensor on port 1 by default. Then we have our main sequence 4 if you're running sequence 4 fastest time. Inside of here we have our sequence variable, which it reads it and then adds 1 to it when it is triggered on the second port for the second sensor, where if it's not triggered, there's just a default smiley face on screen, so you know that it is running the default line tracking at that time, which here you can see it has the line tracking before it enters a sequence. But if that sequence is triggered and we're in the true state, then it adds 1 to sequence. By default, it is set to 0, so the first sequence in it is 1, default 0. It reads the value here in a switch. Then it enters the first state on the first corner, which we have a MyBlock defined as right turn T. And before we get further into the sequences, here we have the image of our maze where we're starting from and finishing. And so turn 1 we have labeled as 1, turn 2 is number 2, turn 3 is 3, and 4, 5, and 6. That is our complete sequence to the finish. For 1 we have a right turn T, 2 is an upside down left turn, 3 is a left turn T, which is the same as 5, and 1 is the same as 6, so the only remainder we have is 4, where we go straight, and 5 and 3 are defined as a left turn T, while 1 and 6 are a right turn T. Since we're in here now, on the first corner, it is the right turn T, and this is the code we currently have for the right turn T. Then we have 2, which is the upside down T. This is the sequence for that, the code that is needed. And I'll just go over it real briefly. It enters the turn and uses the second sensor to on and off track the line. So it has to get off of the current line that triggered it, and then it has to get in the white zone, and then it has to find the next line, and then it has to get off of that line that it just found, or it will trigger again. So that is the right turn T, the upside down T, is a little bit similar, but it uses the first sensor and then the second sensor and then the first sensor to do the same concept. And then the third is just a basic left turn, and then it can enter back into its normal line tracking. Nothing additional is necessary, so we're not going to define a custom block. The only way we're defining custom block is if numerous light sensors are needed. And then we have the fourth intersection, which is a straight. We have it veer off to the right a little bit so that it doesn't interfere with the line. And then the fifth is just another left turn, and then it can go back to the line tracking mode. And then the final turn is the right turn T, which is the same as the first turn. And there we have our complete video.